This video will be about integration using partial fractions. Alright, so before we do anything with integration, let's just look at a fraction with a polynomial in the denominator. If we want to split this up into partial fractions, or two smaller fractions, the first step is to factor the denominator. So that's going to give us 3 over x minus 3 times x minus 2. And so now we know that this fraction is equal to something over x minus 3 plus something over x minus 2. And since I don't know what these values are, I'm going to put in some variables. I'll call the first one a and the second one b. So how are we going to find out what a and b are? Well, if we were given this expression to start with, we could change it into one fraction by multiplying out. So that would look something like a times x minus 2 plus b times x minus 3 over x minus 2 x minus 3 equals our 3 over x minus 3 times x minus 2. So from looking at this, we know that this numerator is always equal to this numerator. Okay, so now we have this equation, and we know that this is true for all x. So what we can do is plug in some sample values of x to see if we can solve for a and b. Usually some good sample values to plug in are values that will make the things here equal to 0. So for example, I'm going to plug in an x equals 2, and then that'll tell me that a times 2 minus 2 plus b times 2 minus 3 equals 3, or that negative b equals 3 and b equals negative 3. Now, to find a, what I can do is plug in x equals 3, and then that'll give me that a times 3 minus 2 plus b times 3 minus 3 equals 3, or that a simply equals 3. And now that we know that, we can go back to our first beginning fraction, and we'll just say that this equals 3 over x minus 3 minus 3 over x minus 2. The third rule says that if you have in the denominator a quadratic that doesn't factor anymore, and let's just say you have some other terms, then instead of doing a regular a over your quadratic, you would have to do an ax plus b, and then do your plus c over whatever your blob was there. Similarly, if you had something that was raised to the power of 3 in the denominator that didn't factor anymore, in the numerator you would have to have an ax squared plus bx plus c. So basically, whenever you're breaking things up into partial fractions, the degree of the numerator has to be 1 less than the degree of the denominator. At this point, we can look at an example integral to see how partial fractions might be useful. If we had an integral like the one shown here, we wouldn't be able to solve it using the methods we've already learned. U substitution wouldn't work because the derivative of the denominator would be 2x minus 1, which we don't see anywhere. So in this case, we're going to have to use partial fractions to divide this up into two terms. So we'll start by factoring the denominator. And that'll be x minus 3 times x plus 2. and then we'll set that equal to a over x minus 3 plus b over x plus 2. So now that gives us the equation here. At this point, we can say that 3x plus 11 equals a times x plus 2 plus b times x minus 3 for all x. So this means we can plug in an x equals negative 2, and that would give us 3 times negative 2 plus 11 equals a times negative 2 plus 2 plus b times negative 2 minus 3. And so on this side we end up with negative 6 plus 11, or 5, and over here we have negative 5b, which gives us that b equals negative 1. Then we can plug in x equals 3, and so that'll give us 3 times 3 plus 11 equals a times 3 plus 2 plus b times 3 minus 3. So 9 plus 11, 20 equals 5a, meaning that a equals 4. So now we can say that we are integrating a over x minus 3 plus b over x plus 2 dx. And we know how to do both of these integrals because we can just use u substitution and let u equal x minus 3 in this case and x plus 2 in this case. And so we get for our final answer 4 times the ln of x minus 3 minus the ln of x plus 2.